gas X has no effect either on damp red litmus paper, so it's not ammonia, right? That's the test for ammonia. It's not ammonia. Or damp blue litmus. It's not acidic either. I think they're looking for CO2. It's not CO2 or SO2. Those are the two acidic gases I can think of. Or even HCl, that's a gas. Puts out both a glowing splint and a burning splint. So it's not hydrogen, it's not hydrogen, it's not oxygen. Let's see. Ammonia is out, carbon dioxide is out. Could be chlorine, could be nitrogen. Actually, chlorine will do what to litmus paper? It'll bleach it out, it'll turn it white. Right? So chlorine's out. The correct answer is nitrogen. In which substance is each carbon atom covalently bonded to only 3 other atoms? Sounds like graphite to me. So carbon can make 4 bonds, right? Especially in organic, we see that a lot. So it can make 4 bonds, and it does so in everything except for graphite or graphene, where it makes these hexagonal things. So if you notice, each atom is actually bonded to 3 other atoms. What happens to the remaining 1 bond? Well, that's delocalized. These tiny green things are electrons, and that's what allows graphite to conduct electricity, and graphite is part of our answer. The answer is C. A student adds marble chips to hydrochloric acid. Marble chips. Those are calcium carbonate. Right, what's going to happen is calcium carbonate is going to react with 2 molecules of HCl, right, to form calcium chloride, carbon dioxide, and water. Interesting, right? From the products, carbon dioxide is a gas and it'll just phase away. So the net mass in the thing is decreasing, and it'll decrease. So the mass will definitely decrease, but it'll decrease, kind of like this. It's very steep over here because the reactants are producing a lot of carbon dioxide early on, because there are a lot of reactants at the start of a reaction, right? As soon as you put chips in there, there's a lot of marble chips, there's a lot of acid that was waiting to get reacted. So a lot of carbon dioxide is produced, so the loss in mass is steep, but over time, lower, and there's the amount of acid and calcium carbonate starts decreasing, the fizzing slows down, less carbon dioxide is produced, so the mass decreases. Think about that for a second. That decrease, the rate of decrease in mass decreases, right? And over time, it just flattens out. So the correct answer is A. A coil of clean copper wire is suspended in aqueous silver nitrate. Crystals of silver are deposited on the copper wire. Okay. Which statement is not correct? The copper is oxidized. The copper is actually turning into a solution, so copper metal is losing electrons to form copper ions. That's all it can do. So this is loss of electrons, that is oxidation. This is incorrect. This is indeed oxidation, right? Total mass of the crystals of silver increase gradually. The total mass increases, well, over time it's going to increase, right? So yeah, that's not our answer. I think I said this is incorrect. It is correct, and we're just looking for the incorrect statement. So yeah, the total number of positive ions in the solution is unchanged. Yeah, that is interesting. The total number of ions is unchanged. So this is confusing me a lot because these statements are correct and I'm looking for the incorrect one. Okay, the total number of positive ions in the solution is unchanged. That's interesting. Think about it this way. Law of equivalent exchange. Silver exists as a positive ion and it'll gain 1 electron to turn into silver and deposit on the copper wire, right? Now copper can give out 2 electrons. So because the amount of electron exchange needs to be balanced, because if this happens a lot more than this, right, even more than the ratio specified, so the solution will have a lot of electrons. That can't happen, right? Like what's going to happen to all those electrons? And vice versa. If silver is taking all the electrons, where will the rest of the electrons come from? So as copper is producing electrons, silver has to take those electrons, and the net exchange should follow a balance, right? But over here, when there's one little issue still, the 2 electrons over here. So over here there need to be 2 electrons, which will be consumed by 2 silver ions to produce 2 silver, right? So each time 2 silver ions are taken away from the solution to turn into silver, 1 copper ion is produced. So the total number of positive ions in the solution is unchanged, is actually untrue, right? For every 2, essentially what's happening is for every 2 silver ions turning into silver metal, 1 copper is turning into an ion. So of course the total number of ions are decreasing. Solution turns blue, that's absolutely true. Silver is being taken away, more and more copper is being deposited. Copper ions will have that distinct blue color. And yeah, that's a correct statement. I think I left how I was marking these with my thought process, because this is a correct statement, this is a correct statement, this is a wrong statement, this is a correct statement. Correct answer is C. Which of the following has not been prepared by reacting a carboxylic acid with an alcohol? So you'll form an ester, right? You'll form an ester. And taking a closer look, we just have to identify our ester linkages. I think that's the easiest thing we can start with. I don't know where this question is going. That's our ester linkage. That's our ester. Oh, wait. What do you know? It's not an ester because it doesn't have that second oxygen present. That's missing. So that's our culprit, right? Even in the last one, that ester link is there. No ester link, ester, no ester. This is not an ester. Answer is C. Which compound is obtained by the oxidation of ethanol? So it's gonna oxidize and turn it into carboxylic acid, which will have a formula C. Well, it's difficult to say C2 and then completely write the formula. So you'll change the formula a bit. So CH3, COOH, or CO2H, same thing. So that's what's going to change. And we have that here. I thought this was it, but there's another carbon. That's out. I think D is our answer. That's not even an acid. That's an, I was going to say ester, but write acid. That's an ester. This is an alcohol. Answer is D. What is the empirical formula for ethanoic acid? So carbon to, let's go with Fine, let's go with hydrogen. Carbon to hydrogen to oxygen. You have two carbons, you have four hydrogens, you have two oxygens. That's 1, 2, 1. So it's going to be CH2O. CH2O, A is our answer. Solid ammonium chloride decomposes on heating according to the following equation. So you have ammonium chloride producing ammonia and hydrochloric acid, and you have a porous plug. The porous plug, what it's doing is, I think it's going to prevent splashes of this liquid, right, or solid, and allow the gases to escape. Okay. There's no splash because it's, yeah, you know. What change occurs to the damp red litmus paper in the experiment above? Remains red? It's not going to remain red. The issue, the real challenge is that both ammonia and hydrochloric acid are being produced. Yeah. So it remains red. That is not going to happen. It will definitely do something. Will it bleach? No, it's chlorine that does the bleaching. There's no chlorine, there's only hydrochloric acid, so it won't bleach. That is out. Turns blue and remains blue. So that's a likelihood. And turns blue and then it can turn red, right? Now, I think the examiner forgets to understand, it's not really highlighting that each gas is produced at the same time. So every time ammonia is produced, hydrochloric acid is produced. So it'll just, you know, mess around with the damp litmus paper, and I don't think you'll have a consistent anything right now, right? Unless this was very far, like a very big chamber. I think what they're going for, what they definitely are going for, is diffusion, the rate of diffusion. The lighter the gas, the faster it'll diffuse and will move away, and the one to stay behind will dominate the color on the litmus paper. So between the two, which one is heavier? Nitrogen has a MR of 17 and HCl has a MR of 36.5. Hydrochloric acid is a lot heavier, so it'll stay behind and dominate the litmus paper. So it's going to turn blue first, then it's going to turn red. So the correct answer is D. Which material has the highest melting point? Ammonia, methane, sodium chloride, water. So out of this, you have a simple covalent structure, simple covalent, and you have an ionic substance, which is going to have the highest melting point. Other way to figure this out is, well, you're looking at a gas, a liquid, and a solid. Which one do you think has the highest melting point? Because three of them, like one of them has already melted at room temperature, and the other two are gases way past melting. The correct answer is C. The table shows some properties of diamond and graphite. For which property is the reason correct? Diamond cuts glass. The bonds in glass are stronger than those in diamond. I'm not going to dignify with that with a response. This is out. Diamond is a hard substance. There are many ionic bonds in diamonds. No, they're covalent bonds. Graphite is a lubricant. There are weak bonds between graphite layers. Oh my God, we hit the jackpot. Graphite conducts electricity. Graphite contains free moving electrons. C. Which statement about the substance formed when a given mass of an element burns in excess oxygen is always correct? The substance formed is a, I'll have to read that again. Which statement about the substance formed when a given mass of an element burns in excess oxygen is always correct? Denser, greater, soluble, white in color. Well, it makes sense if it's greater in mass because it now has oxygen added to it. B is our answer. Density is about how much volume you take as well. Mass is definitely increasing. That's what we're discussing here. But like carbon is more dense, but carbon dioxide is a gas, so way less dense. So this is incorrect. Soluble in water depends. You have insoluble oxides as well. White in color, you have, they're not always white in color. So correct answer is B. Which reaction does not involve neutralization? And if I'm taking a closer look, I think barium is displacing the hydrogens, right? This is a displacement reaction. So this is not neutralization. Neutralization. The first one is an acid meets a base. By the way, this is not a base, so that's also another indicator. This is an acid with a basic oxide and acid with an actual base. So B is our correct guess. The table gives information about solubilities of hydroxides, carbonates, and sulfates, calcium, sodium, and zinc. What is the best way of making zinc carbonate? Zinc sulfate, aqueous zinc sulfate. So you essentially want two aqueous zincs mixing together, right? You have aqueous zinc sulfate with aqueous sodium carbonate. If the one of the salts in the product is insoluble, it'll definitely be made just by making two soluble salts. That's the theory, right? So I think in every other case, you'll see that there's at least one solid or two solids. So A is our answer. All ammonium salts on heat with sodium hydroxide produce ammonia. From which ammonium salt can the greatest mass of ammonia be obtained? Greatest mass implies greatest ammonia. So can I be confident in saying that the three ammonium ions and each ammonium ion produces ammonia? So if you have, 0.5 mole of this entire thing, you're actually going to produce 3 times 0.5, which is 1.5 moles of ammonia, because you have 1.5 moles of ammonium ion over here. So essentially over here, I'll be multiplying this number, the number of ammonium ions, with the moles present. The largest number should be our answer. For second one, it's 0.5 times 2, which is 1 mole. That's losing our battle. That's still 1 mole. Last one is also 1 mole. And the last one could be 2 moles if they have aluminum added to it. If they add aluminum, nitrate ions can react with sodium hydroxide with the presence of aluminum to also produce ammonia. I think the clear winner is, for now, A. A 10 centimeter sample of gaseous hydrocarbon is completely burnt in oxygen. The total volume of the product is 70 centimeter cube. Which equation represents the combustion of the hydrocarbon? Now this question is incredibly incorrect. I want to sue Cambridge right now for this question because they're taking the water into account. Water as a gas. This is just malpractice on their part, right? They're taking water into account. Water is at room temperature, RTP. This is at room temperature. It's going to be a liquid, so its volume does not account for, for the moles it has. So its volume is going to be based on its density rather than how many moles of it is. But in gaseous form, that means this is not at room temperature. So if it's not at room temperature, what's really is going on? Like, have they set the temperature straight? Because it's going to be an exothermic reaction. Gas is going to heat up. Normally with these sort of questions, when they're talking about moles, they wait for the gases and everything to cool down, because then you'll see that this is always a liquid and this is always a gas. Anyway, they just want it, this is essentially what they're looking for. It's such a stupid question. CXHY reacts with oxygen to produce some amount of carbon dioxide, and let's go with, I've already used Y over here, I don't want to use that. Let's go with A amounts of H2O. So essentially X plus A, these two values, the sum of them need to be 7, because with that would imply 10 centimeter cube. Will produce a total amount of products which are 70 centimeter cube. So looking at the options, I'm looking at 3 and 4 being a sum of 7 where there is a 1 over here. So this is the correct answer, so to speak.